Back again, I'm Tom Hoax from Verantis. We've provided 4 fans. We built 2 of them and we bought 2 of them. This book is all information that's something for you to play with and hold while you're sitting here so you don't get too bored. It's information out of the training manual, out of the O&M manual. It's only the stuff that I deemed important enough to copy. So, not too much stuff in here. We'll go through this. It'll cover some of the basic information, and I'll cover a couple other points, and then you'll have a fairly decent understanding of the fans, hopefully. Good enough so you can take care of them and do what you need to do with them. If you open up the manual and you go in, the first page, that's actually a page, is a drawing of the 2 Verantis fans. They're model 4450 fans. That means they got a 44-inch wheel in them. They're designed to do 25,000 CFM at 1,202 RPM. And maximum RPM that this fan's allowed to do is 1545, so it can be sped up some more if you need more air movement. It's designed to operate at about 11 inches of static pressure, and brake horsepower usage at that speed and airflow will be about 53.85 brake horsepower. It has a 60 horsepower motor on it. So that's the information that's on there. That drawing also gives you all your physical dimensions of the fan and location of all the pertinent parts. The next page is the fan curve for the 2 Verantis fans. The fan curve, the reason I put this in here is because the static pressure at which a fan is operating is very critical. If you were to drop the static pressure from 11 inches down to say 6 inches, your airflow volume will go up from the 25,000 to somewhere around 38,000 CFM, which will raise the amperage on the unit, make the belts work harder, generally make everything work harder, run up the amps, and you could possibly, this fan will run, the motor will run that much horsepower, but on other fans it won't. So when you have a fan, you want to make sure that you're operating in the design parameters. Okay, next page covers the big green heck fan. It's a 36-inch tube fan. It's located up on top of the roof of whatever building that is over there. It's designed just for bypass air, I guess. I don't know what I'm not into that. But the fan curve is here. This fan is designed to operate at 3 inches of static and 25,000 CFM also. It has a 25 horsepower motor on it, and it operates with a 22.81 brake horsepower. This fan will operate at 1,193 RPM standard operation. The last fan is the little green heck, and that's going to be installed in the ductwork in the top of the incinerator room. It's not installed yet, so I haven't done anything with it.
So it's sitting there on the catwalk this morning.
It's a 3,600 RPM motor on it, 3 horsepower, and that fan will be designed to operate at 3,603 RPM at a static pressure of 3 inches, 2,100 CFM. The reason I put the next 2 sheets in here is this is our bearing selection for the Verantis fans. It tells you on the second sheet that your bearings, your outboard bearings, should be greased every 0.7 to 1.03 weeks with 0.26 ounces of grease for 24-hour operation. And the inboard bearing should be greased about every 4 weeks with 0.25 ounces of grease. So there's frequent greasing on these fans, and the same thing with the green hex, and we'll cover those in a minute. The next page covers the motors on the Verantis fans. The reason I put this in is because the brake horsepower is 400, and the brake amperage, lock rotor amperage, 435 amps. And quite often places have trouble with that kind of an amperage, but these fans are on VFDs, so you should have no problem with them starting or anything like that. These fans are on VFDs, the other 2 are across the line start, so it makes a big difference in the belt wear and tear. Your next couple pages, 3 of them, cover the greasing for the motors. on the Verantis fans, and all motors are basically the same. It says basically we're using a lithium-based grease. The second page, if you pick out an 1800 RPM motor, we're looking at about every 3,000 hours for greasing those motors, which is about every 4 months. The third page tells you that you need to use in between 30 and 40 grams of grease, which is about 2 or 3 pumps. And that's the greasing of the motors. All 4 of the motors will fall under that same general rule as far as greasing goes. The next page covers the greasing of the shaft bearings on the green heck fans. The smaller fan is doing, yeah, I have the RPM, 3,600 RPM. So that's going to be greased on a weekly basis. The larger fan is doing 1192, so if you look at that, they're looking at greasing that every 2 months as a general recommendation. The next page covers your basic types of grease. We're all lithium-based greases. Any lithium-based grease will do. The company just prints out a list of names, so if anybody has any questions, they can have an idea what kind of greases that are here. I guess you guys are using mostly Mobil or Golf or something, Mobil. So they'll be compatible without a problem. You don't want to switch over and go to a synthetic grease because they don't mix in the bearings. They separate and will fight each other actually. The next page covers the Verantis fans, the drive selection. Tells you what your shivs are, what your pulleys are, that you have 4, 5V, X, 860 belts. The center of the top of the page has a belt installation heading, and that gives you your deflection of 0.43 inches with about in between 12 and 18 pounds pressure applied halfway between the center distances, 2 shafts. You should have about 0.43 inches of deflection, and that'll give you the proper deflection and proper tensioning on the belt. The way they come up with this 0.43 inches is 1/64 of an inch deflection for every inch of center distance on a fan. So if you have other fans and you have a 32 inches center distance between the 2 pulleys, you take 32/64, half an inch deflection. And on the next page, we cover alignments. And when you align your shivs, you got to make sure they're aligned both horizontally, vertically, and that they're in line and not tracking off to one side or another. Hopefully everybody's experienced in that and won't have a problem. Use a string, it makes a good way to do it, and it's very straightforward. Put the next page in because depending on which type of belts you have, that bottom lower right hand corner gives you your type of belts and the pounds pressure that you should use to tension the belt to give you the proper. You can figure out the deflection distance with 1/64 of an inch per inch of span, and you apply the amount of pressure indicated in the chart per the particular style of belt, model of belt you're on. A VX or a V belt, 3, 5, or 8, and that'll give you the proper pressure to apply so you can make all your belts tension properly. The last page in here covers general recommended maintenance on the fans, which are mostly grease it and inspect it from time to time, because if you inspect it from time to time, you'll see when the belts are acting up and you keep it lubricated, everything should last a good long time. The belts on the Verantis fans have that, like I said, they're on VFDs. If those belts are kept tensioned, they'll last for years. The cross the line start fans tend to chew up belts a little bit quicker. And that covers everything in there. A couple other points that I wanted to cover. The Overly Halts motor bases that the motors are mounted on. When you go to adjust the motor base, you have 4 hold down bolts that hold down the motor. And then you have 2 jack screws to pull the motor to the side. When you go to tension the motor, you loosen all 4 of the hold down bolts, you run the jack screws back to pull the motor back to where you need it. When you go to tighten the motor back up again, tighten up the back 2 bolts first and then release the tension on the jack screws. When you're using those jack screws to pull back on the motors, the bolts tend to cock crooked. And if you don't loosen up the jack screws so they can come back up straight, they're going to tighten down like that. And we've had people bend the bolts, and that sort of makes them not work really good and gives people problems later on trying to make them work because the bolts are bent. So if you loosen up the jack screws, then you can tighten down the two front ones. Tighten down the back two, that'll hold in place, hold the motor in place, loosen up the jack screws, and then lock down the two front ones. And that'll give you a good solid mount. Otherwise, when they're on an angle, they can vibrate loose, or like I said, you can bend the screws. And that basically covers the fans. Basically, quick maintenance is, inspect them and lubricate them. If the belts get loose, you keep the belts tensioned. Shouldn't have any problems with them. They'll last a long, long time. If the two big Verantis fans are on manual dampers, so if somebody were to go and during a hot summer day switch from one fan to the other and not go out there and open a damper, you could be running that fan deadheaded. If you're running a couple days deadheaded in very hot weather, could destroy the fan. It's got basically about 180 degree rosin in it. So if that fan gets up over 180 degrees, which running deadheaded, it will happen, it can happen, the fan could disintegrate. New York City knows it for a fact. They blew up 7 of them doing it on one project, doing it like that. The operators went and switched over. They didn't have the SCADA fully working. The operators went and switched over from one set of fans to the other. Didn't bother opening any of the dampers. Let the fans run over a weekend in 100-degree weather. Blew up 7 fans. Not covered under warranty when they do that. Belt tensioning. Normally, I say, check them daily for the first week, weekly for the first month, monthly for the first 6 months, and after that, you're back on your normal schedule, which is probably every 6 months. But you're better off to check them more often than less, especially at the beginning because belts always stretch. Any questions?
I'm guessing that balance plays a pretty good role in how the fan, in the life of the fan. What sort of things have you encountered that would throw the balance of the fan off?
These fans are balanced very good. They come in I check the vibration on them when I set them up. They're balanced good. You could build up dirt on the impellers. There's an access panel on the back of the two Verantis fans. You don't have that on the Green Hex. You can open it up, check the inside of it. It's recommended on the sheet, I think, every 6 months to do that. And if you have to, you take a high pressure sprayer, clean it out, blow it out and stuff like that. Now that fan's going to be drawing from upstairs and going into the bottom. It should be fairly wet air that's coming out, and if it is, you normally won't get a lot of buildup. Anything that's on there should fly off, but it is recommended to check them. Keep that from happening. And if you see anything bouncing or acting funny, when you look at them, they run fairly steady. Right now, they're not running real good because I was running them with the ductwork all off. So we're fighting air, and I've got the damper closed down halfway, which gives you a real crazy turbulence inside of them. But the vibration still came in the very good range as far as checking the vibration on the main bearings.
Speaking of dampers, dampers are run full open all the time. There's no throttling.
Well, that's why I mentioned the static required. The two big fans are designed to run at 11 inches. The two little fans are designed to run at 3 inches. If you drop that static off, then the fans are going to move way too much air. And you could end up ruining the bio bed by moving too much air through it, drying it out.
I don't know if you know what they're incorporating.
Until they get the rest of the system running and get a complete system balance done, I couldn't answer that question. Right now, I had to run them halfway closed to get to 11 inches.
So there's got to be pressure switches built in, flow switches and pressure switches built in.
I don't know that they are.
Control it then, right? Especially if you're running them on VFDs and get a set point.
Well, the VFDs serve two purposes. The first one is soft start, but the second one is instead of running a fan at full speed and dampering it down to get the 11 inches, you don't need the 11 inches on the fan from that point of view. If the balancer were to actually check airflow, set it at 25,000, running the fan at 43 hertz versus running it at 60 hertz, then you don't have to worry about the 11 inches. You don't have to worry about that. It's a better way, the cheaper way to run the fan too, less power usage. So they might do that. I don't know what the process is going to be here.
Yeah, it's got to be some sort of flow switches and pressure stuff on it.
because the biobed, if you dry it out, you kill it. If you if you get it filthy, it blocks up. So you'll have issues from that point of view, but they're supposed to be watering it well. So, any other questions? Does anybody? You guys want to walk outside and take a look at them?
Yeah, might as well.
I mean, there's not much to see because they're not, like I said, piping's not done, but we can do that. And then if you have any questions, we can handle it out there. That big lid goes over on top of here. I don't know why somebody took it off, but it's off. It was on, then there's a couple screens that go on to underneath so you can't reach up in to get your finger in the belts. And pretty straightforward as far as that goes. 2 bearings, motor. Any questions? And they'll get done with that someday. They have nice weather for it, at least right now. That duct goes up across the roof into the 36-inch green heck is up on the roof, and it's actually sucking out of these 2 rooms, the biofilters, and then it takes it and blows the air over, and it's going to tie into the stack, I guess, the way it was explained to me. And the smaller fan, 17 inches inside the top there, and it's just supposed to boost the airflow in that big crossover duct. I don't know where it's tied to or where it comes from. I'll be back probably to start that one later when they get it installed finally. So that's it. You have emergency stop buttons out here on these 2. On the one on the roof, you do have a disconnect and
No
a
start-stop out here, just E-stop.
just E-stop. VFDs are inside the control room there, power room. On the roof, you have a disconnect on it and a manual auto selector switch off. I don't know what's going to be up on the mezzanine because it's not there yet. Any other questions? I think you're good.